Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Anelen Sindane. The lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. I hope you wrote your paper 1 well. It is over. Let us now focus on the revision for paper 2. The topic, it's mathematics paper 2 revision, and we will mostly look at trigonometry and Euclidean geometry. We are aware that for paper 2 these topics contribute 90 marks, and we can easily get our 60% from this paper if we get all the marks correct. Now, we know that paper 2 has 4 topics: statistics and regression analysis. We also have our analytical geometry contributing 40 marks, statistics 20 marks. I've already mentioned that trigonometry and Euclidean geometry are 50 marks and 40 marks respectively. The total is 150 marks. I have tried to make a breakdown so that we are able to see how we can score these marks. For statistics, we can get 12. Analytical geometry, we can get 15. And for our trigonometry, we can get 20. Then that will give us 57 marks, which will give us almost 45% needed for us to pass. And then if you check for our bachelor passes, those are the breakdown for the marks per topic that we can score so that we are able to get 100 marks. And we know that for us to pass, we only need 75 marks. But remember, the higher you score, the better, because it puts you at an advantage of getting a better symbol as we move forward. Now, paper 2 is easier than paper 1. I know most of us will dispute. We only have 4 topics versus the numerous topics that we have written in paper 1. Now, I will not dwell much on the cognitive levels, but we are aware that for our paper 2, knowledge and routine procedures also contribute 20 and 35%. That's about 55%. And we are able to pass with our level 1 and level 2 questions. And then we also have our complex procedures and problem solving, which contributes 45% of the whole paper. So let us practice so that we are able to score the mark that we need to take us to a better level. Now, we have our information sheets. I have only looked at those aspects that deal with paper 2. For statistics, we have our mean, we have our variance, which will also help us to get our standard deviation. And then I also have for our regression analysis, mostly this will be calculator work. Please make sure we practice our statistics, the grade 11 part as well as the grade 12 part. That's 20 marks. We can easily get those 20 marks if we are practicing well. Then we have analytical geometry. We have our distance formula, our midpoint formula. We also have our equation of a straight line, as well as the gradient formula, as well as the angle of inclination and the equation of a circle. That's our formula for the topics. And then we have our trigonometry, our sine rule, our cosine rule, as well as our area rule. We shall use this one to solve our 2-dimensional and 3-dimensional problems that we will practice as we move along. And then we have our compound angle identities that we did in grade 12. They are there in our formula page. Please let's refer to them so that we do not lose marks by writing wrong formulas, yet we are given a guide for us to get the correct information that we can easily substitute and rearrange in order to solve whatever the question is looking for. Now, for trigonometry, we are going to look at problems that involve the Pythagoras theorem. We know those problems. We are going to look at reduction formula. We are going to look at identities. Our special angles, by now we know them. General solutions, where we look at our trigonometric equations. We have our trigonometric functions. We look at the effects of A, P, and K. We remember this. And then we have got our compound and double angle identities. The formula I have shown you. We are also going to look at the applications of trigonometry to solve two-dimensional and three-dimensional problems. Our area rule, sine rule, and cosine rule. These are the aspects that we are going to remind each other on. Now, I will start by summarizing our cast diagram and our reduction formula so that we quickly remind ourselves on how this works. We know that in quadrant 1, our x and y values are positive. That is why when we do our reductions, we have our x and y being positive. Remember, we drop a perpendicular so that we have a right angled triangle, and we use our theorem of Pythagoras to solve for x, y, and r, depending on the information that you are given. In quadrant 2, we know that our x is negative and our y is positive. That is why our reductions for sine will be positive because our y value is positive, but our x is negative there. That is why the reductions will give us negatives. In the third quadrant, remember, we only do constructions of verticals. We do not do horizontal constructions there. Ne? And in quadrant 3, we know that our x and y are both negative. Hence, the sine and the cos are going to be negative in the third quadrant. And in the fourth quadrant, we know that our x is positive and our y is negative. That is why our sine and tan are going to be negative there. We also have our identities that we did in grade 11. Cos squared theta plus sine squared theta is equal to 1. We should remember how to do that proof. It might be asked, but we did it in grade 11. We also should know how to use tan theta as being sine theta over cos theta. That's an identity. We can easily use it as given. To just remind ourselves of our reduction rules. Second, on the first quadrant, we can have theta or 90 minus theta as our angle, and the reductions will work like that. Second quadrant, we normally use 180 minus theta, or we use 90 plus theta, and the reductions are like that. And I will encourage you to always, when you are doing your reductions, please use brackets so that we take care of our signs. Otherwise, we lose track of signs and we end up losing marks because our reductions will not be having the correct signs as we are referring to the cast diagram. Remember, our cast diagram, we are using our Cartesian plane as well as our revolution. We know that on the x-axis is 0 degrees, y-axis 90, we have 180, 270 degrees, and 360 degrees. That is why in the fourth quadrant, we normally use 360 degrees minus our theta. And we also use our negative angles, which are in the fourth quadrant, as we are moving in the clockwise direction, because now we are moving in the anti-clockwise direction for our reductions. I hope we can quickly remind ourselves of this. Now, when we are dealing with reductions, whenever we have an angle which is more than 360 degrees, we can easily subtract 360 degrees so that we end up getting an angle which is less than 360 degrees, and we are able to apply our reduction formula. Sometimes you are given questions where you are supposed to reduce sine 90 plus x. This is straightforward, but then it changes. You are given sine, for example, you are given sine x minus 20 degrees. This can be easily done. Now, what becomes a challenge? It's when you are having x minus, for example, 180. We know that our angle is always the first one. It's either 180 minus 180 plus. But when it's now sine x minus 180 degrees, we know that we can either factor out a negative, or we just add 360 degrees so that we work with positive angles and our reductions are going to work well. That's another thing that we need to talk about now. We move on to the next slide. I would want us to quickly do that activity 1. It's revision. We still remember these things. I just want to check how much we still remember. I will give you about 5 minutes to quickly solve that question 5. Welcome back. I hope you enjoyed practicing the first activity for the afternoon. Now, before we go to the answers, I just need to highlight a few things. On this question, read the information well before answering the question. Otherwise, we might get things wrong. Let's read. The information is given there. The diagram, second quadrant, you are given the information. The alternative way in which this question can be asked, you might be given something like this. You are given that 25 sine theta minus 24 is equal to 0. They can give it in that way. And if the question is given like that, you will be required to make sine theta the subject, which will give us 25 sine theta is equal to 24, and we'll get our sine theta as 24 over 25. Now, you will be expected to draw the diagram that you are given now to help you find the value of k and to solve for whatever the question is asking you. Let's pay attention, because if you check there is a keyword there. Without calculating the size of theta, determine the value of the following. Sometimes it's given as without the use of a calculator, determine. So we have to be careful. The moment we see an answer with a decimal, or the moment you evaluate the size of angle theta there, it's a breakdown because you did not adhere to instructions. So we need to be careful. These are the questions that require us to use the theorem of Pythagoras, and we must use a diagram, and we must not use our calculators. We can use our calculators to evaluate, but we cannot calculate the sizes of the angles or leaving our answers as decimals, because it shows we have used the calculator in this case. Let's move right along. If we check, it says without calculating the size of theta, determine the value of the following. We are using our cast diagram, and this one, it's easy. The diagram is drawn for us. So for 5.1.1, we are supposed to find the value of k. So we are going to do a construction, form a right-angled triangle. Then we are going to use our theorem of Pythagoras, because our k is the x value, our 24 is our y value, which gives us the other side. And then we are able to use our theorem of Pythagoras. Our x squared plus y squared is equal to r squared. And then we substitute. Our x in this case is k squared, plus our y in this case is 24, and our r is 25 squared. And this will give us our k squared as 49. But when we solve for k, we are getting k squared as 49. Remember, our k can either be positive or negative depending on the quadrant that we are dealing with. In this case, our k can be positive 7 or negative 7. We are looking at the diagram. In quadrant 2, x is negative. That is why we are taking the negative value of k as negative 7. So this question was 2 marks. So we will get our mark for using the theorem of Pythagoras, substitution, and the correct k value of negative 7. Using theorem of Pythagoras and substitution, we get our 2 marks there. The next one, we are supposed to evaluate tan theta. Tan theta, we know that tan, it's y over x. We have found our x as -7. So the coordinates here are -7 and positive 24. So our tan theta will be given by our y, it's 24, and our x is -7, giving us -24/7 as the answer for tan theta. We get our 1 mark there. We move on to the next one. We are supposed to find sine alpha if theta plus alpha is equal to 360 degrees. This one is 3 marks, which means there's some bit of work that we need to do there, because there is alpha that we didn't have. Now we are having theta that we were given. How do we juggle around? We did this in grade 10, mostly changing the subject of the formula. So we want to make alpha the subject. It will be given by 360 degrees minus our theta. Remember, we are dealing with theta, so we are able to use our reductions in this case. From there on, I know that if I have sine 30 degrees, it will be equal to the sine of, for example, I can use 90 degrees minus 60 degrees from our reductions. You remember that one. So that I have my 30 degrees, I have my 90 minus 60. 90 minus 60 will give me that 30. So these should be equal. So I can introduce sine now, and I will have sine alpha is equal to sine 360 degrees minus theta in brackets. And I know that sine alpha will be equal to, I can reduce this from my reduction formula. Sine 360 degrees minus theta is in the fourth quadrant, and in the fourth quadrant it's negative. I'll get negative sine theta. I already have my sine theta there, and I have my sine. It will be 24 over my hypotenuse, which is 25, and that should give me negative 24 over 25 as the final answer. You are able to see that one then. We move on. It was 3 marks. So for making alpha the subject, you get a mark. And then introducing sine and the reduction, then we get our answer. We get our 3 marks there. We move on to the next question. We are supposed to evaluate cos squared alpha minus sine squared alpha. Now, we are going to substitute my cos alpha. It's x over my r. My x is -7 over my r, which is 25. I square this minus my sine. I have evaluated it. It's 24 over 25. My y over x. Remember, cos is x over r. I'm squaring this minus sine. It's y over r. I'm squaring that. Then I should get my answer there as this. So we'll get our answer as negative 527 over 625. Without using a calculator, don't go ahead and simplify this and press your fractional button, then it gives you 0 comma something. Negative 0 comma something, it becomes wrong. You have used a calculator. Don't use a calculator in these questions. Just leave them as fractions like that. We move on to the next part. I will give you 6 minutes to attempt the 5.1 up to 5.3. 6 minutes. Let's quickly attempt. We are revising, so we are checking how much we still remember here, and we are going to work together to get these questions right later on. Welcome back. I hope you have attempted the questions there. Now, this is part of our reductions where we use our identities to simplify. The key term there, this must be a single, it says one trigonometric term. Now, you are able to see something there for 5.1. If you check, I'm having sine x over cos x. And I know that sine x over cos x is an identity there. So straight away, I can do my reductions there and get my 5.1 as sine x over cos x will be tan x over tan x. I know that the reduction of sine 180 plus x, it's in the third quadrant, and I know that in the third quadrant, sine is negative. It will give me negative sine x. And the reduction of cos 90 minus x, that's a cofunction. Cos becomes sine, and that will give me sine x. So already I will get a mark for changing sine x over cos x to an identity tan. That gives me a mark, that gives you a mark. Already I will have 3 marks by just doing one step. Please do not waste time copying the question as it is, because it's given on the question paper and the marker has it. Let's answer what is asked. Write the correct number, and in paper 2 we are using a booklet, so you don't have to struggle. Just write the answer there so that we do not waste time in the exam. Now, so I've already indicated that here I will have 1 minus sine squared x, which should give me 1 minus sine squared. Remember the identity, sine squared theta plus cos squared theta equals 1. So if I transpose 1, this would mean my answer should be cos squared x. So for simplifying this to that, I will get 1 mark, and the 5th mark goes for writing that one as cos squared. So if you leave your answer there as 1 minus sine squared, you will get 4 out of 5 if the first step was correct. Now we are able to see that here's an alternative. I changed sine over cos. In this case, the substitution is for sine over cos as the identity for tan. You will get a mark there, a mark there, and a mark there. You already have your 3 marks, and then sine 1 minus sine squared and cos squared will give us the 5 marks there. So there are always alternatives, but make sure that you are using identities. Do not create your own. We move on to 5.2. 5.2, it's something that requires us to use the trigonometry for grade 12. So on the numerator, you know that you have an identity that has sine squared and cos squared somewhere with a minus. So if I factor out a negative on the numerator, I will have cos squared 35 degrees minus sine squared 35 degrees all over. I know that I have an identity with 2 sine alpha cos alpha being equal to sine 2 alpha, like that. Now, so I know that 4, I can write it as 2 times 2 sine 10 degrees cos 10 degrees. Now, if you check, I have an identity which is given by cos squared alpha minus sine squared alpha. Remember, from our compound and double angle identities, I showed this. It will be for sine 2 alpha. I can write this as equal to, I have my cos squared minus sine squared. I know that this is the same as saying cos. The negative sign is still there. It will be 2 times my theta, in this case is 35, over, this will give me 2. I know that this is sine 2 alpha, which is sine 2 times 10 degrees. And this will give me negative 2 times 35. It will give me cos 70 degrees over 2 sine 2 times 10 will give me 20 degrees. But you realize that these are cofunctions. I can now write this as negative cos 70 degrees. I know that sine 20 degrees is the same as saying sine 90 minus 70, and that will give me cos 70 degrees. This cos and that cos cancels, and my answer will be negative half. So 4 marks, taking out a negative, substituting our compound angle, our double angle identities for cos, and simplifying that to give us, changing either cos 70 to sine 20 or sine 20 to cos 70, and our final answer of negative half. So this is how we would have done that question. Very fast, we get our 4 marks there. Now, for these reductions, remember they can either be in terms of x, or they can use compound angles, or we can use our double angle identities. So the most important thing, always refer to your formula page. Sometimes you just need to reverse what you are already given. So always look, there's always something that will help you to get the answer faster there. As you can see, I've highlighted this requires us to use our double angle identities there. Now we move on to the next question. Again, you are given cos 26 degrees as equal to m. We are supposed to not use a calculator, it's bold, without, determine 2 sine squared 77 degrees in terms of m. Once again, refer to your formula page. There is always something that is going to help you. If you look at cos 26, you also look at sine 77. There is a relationship. I know that I can write cos 26 degrees as cos 2 times 13 degrees. And sine 77, I know that I can write this as sine 90 minus 13 degrees. Are we able to see that? 90 minus 13 gives me 77. So there should be a relationship between this cos 26 and that sine 77. As you can see, there is our relationship. That 13 is coming in. So we should be able to see that link. So we are using our double angle identities and together with our reduction formula to help us solve that problem. In the interest of time, I will show you the solution. So we start by using sine squared 77 degrees. We know that it will be given by 2 sine 90 minus 13 squared. And we know that it's a co-function, sine becomes cos, so we'll get 2 cos squared 13 degrees. And we introduce a -1 because for our cos, we have cos 2 theta, we have the first identity, we can use cos squared theta minus sine squared theta, or we can use, in place of sine, we substitute 1 minus cos squared theta. That will give us 2 cos squared theta minus 1. Or we substitute, in place of cos squared, we substitute 1 minus sine squared, and that will give us 1 minus 2 sine squared theta. So it's a matter of playing around with these identities to help us get what the question wants. If you see, you are now having 2 cos squared 13 degrees. You introduce a -1 so that you are dealing with this identity there. You have introduced a -1, you add a 1 so that the effect, you are adding a 0 there to 2 cos squared 13 degrees. It's still a 0, but we know our intention is to get the cos 26 degrees. The cos 26 degrees is equal to m. We substitute, we will get this as m plus 1. The alternative is to use the other identity for cos double angle. You have your 1 minus, we know that it will be cos 2, this is cos 2 times 77 degrees. So from there on, we get 1 minus cos 154 degrees. You see where the 1 is coming from. You take the 2 sine squared 77 to the other side, you rearrange the formula, and then you substitute and you get your answer like that. We move on now to our trigonometric equations. We know there are different methods that we use at school. I will start by explaining the one that involves us calculating a reference angle and using it together with our cast diagram. You saw that if you are solving an equation, that's there is somewhere where you'll get sine theta or sine x being equal, cos x being equal, and then you must get the general solution. So this one, you ignore the negative, you use your calculator, shift, sine, if it's a sine, shift, cos, if it's a cos, we ignore the negative sign. All you are dealing with is the 4 quadrants. You know, if it's negative, you know in which quadrant cos is negative, sine is negative, or tan negative, then you will get your solution in the given quadrants. For this one, we know that sine is negative in quadrant 3 and 4, in which case the solution in quadrant 3 will be given. In quadrant 3, we saw that it's 180 plus theta, or plus our reference angle, and that will be the solution in the 3rd quadrant. In the 4th quadrant, we use 360 minus our reference angle, and that will give us x as 330 degrees. Please do not forget to write where k is an element of integers. Now, the alternative is to use the graphical method. We know our graph of sine, the graph of cos, the graph of tan, and we know that if we are to find the general solution, we know that for sine, we are having something like that. For the cos graph, if we are supposed to find the general solution for the sine, if it was a negative, we want to find these regions where the straight line intersects the graph. It works almost the same way as the one for referring to our quadrant, and you are going to have a number of these solutions that are the same, and you will realize that this solution will always repeat itself after a period of what the graph is having as its period. You can see some I've put X, and on some I have put dots there to show that this solution is repeating itself after a period of 360 degrees. 360, it starts again. We get the new solution like that because our graph is a wave like that. So this is the alternative way of getting our general solution. We can use our quadrants or we can use the graphical method as illustrated here. Do not forget the K. Remember, you are looking at the number of revolutions that are occurring, and this can go either in the positive or in the negative direction. As you can see, the graph is defined in the given regions. Now, for these trigonometric equations again, we have different types. We have got where you'll be given sine x minus 3 cos x equals 0. This one, we know that we cannot substitute anything there to help us solve this equation, but if I transpose, I will end up having sine x is equal to 3 cos x. I divide by cos, and that will give me tan x is equal to 3. Then we can either use the graphical method or the quadrant method, depending on whether what we are having is correct. So this is where you will have the tan form, where you have to change. And then we have the quadratic form, where you will have something like this: sine squared x minus 2 sine x plus 3 equals 0. As an example, we are able to find the general solution of this one. And we can use the quadratic formula if you can't factorize, or you are able to easily factorize and get your solution. And then we also have the ones which is normally brought with graphs, where you are given sine 3x is equal to cos, for example, x minus 30, where you use your co-functions. You must change this so that they are having the same. Either you change them to sine or to cos, and then you use one of them as a reference angle, then you do the general solution. These are the different kinds of our trigonometric equations that we will look at. And also remember, our compound angles, our identities also work with these questions. So you must be able to see which identity can you use to help you come up with the correct equation, factorize if you can, or you are using your co-functions. But generally, once you get your reference angle, the general solution must always have the angle plus k times the period of the given graph, k element of integers. We are going to talk about the period of the graphs after this. For sine and cos, we know that the period is 360 degrees, and for tan, it's 180 degrees. Now, I will give you 4 minutes to attempt question 5.4.
You have been given power
Welcome back. I know this one, it's an unusual one. And most of us maybe struggled to even start with this one. That is why I gave you 4 minutes. But I want us to think outside the box. Let's refer to our formula page. If you look at that, sine x plus 25 cos 15 minus, if you check that one, it's in the form sine A cos B minus cos A sine B. And if you look at our formula page, this is equal to sine A minus B. So we have this on the formula page. All we need to do is to be able to identify the identity that can help us solve this. So we are able to find the general solution, f of x. So where there's f of x, we are going to substitute this part for our f of x, and we will get sine x plus 25 degrees cos 15 degrees minus cos x plus 25 degrees sine 15 degrees equals to tan 165 degrees. And if you check this, where there's a, it's where we are having x, where we are having a, you are able to see that. Where we are having b, it's where we are having 15 degrees. You are able to see that. So it means this will be the same as sine x, that's our a, x plus 25 degrees minus 15 degrees is equal to tan 165 degrees. So this will give us sine, when we simplify, sine x plus 10 degrees is equal to tan 165 degrees. Now from there on, you are able to see that tan 165 degrees, you can use your calculator to get the value, and then from there you are going to see your sign, whether it's this is going to be negative because it's in the second quadrant, and from there on you find your general solution. Now let's quickly check how we are going to do this one. I've already indicated that step. If you use your calculator, it gives you negative 0.2679, and we are here now. We have done up to that step where we get negative 0.2679. From there on, we can use any of the given methods to help us get the general solution. We can get our reference angle. Remember, we are going to shift. We can ignore the negative sign and get our reference angle. Shift sine 0.2679. Once we get our reference angle, we add it because it's negative, so our solution is in the third and the fourth quadrant. So in the third quadrant, we'll get our solution as that, and in our fourth quadrant, we will get our solution as x is 334.46, and that one element of integers. So please, I know that I showed you the three types, the one where you have to change to tan, the one which will end up being quadratic, either use factorization or you use the quadratic formula, or the ones where you are supposed to change one using cofunctions and you make one the reference angle. This is a special one. You are using your compound angles to simplify until you get to the one where we are used to getting our reference angle, and then we get our general solution. So we are going to get our 6 marks, and our 6 marks for being able to simplify up to seeing that this is a compound angle identity, 1 mark. We get 2 sine x plus 10 as that. We get our reference angle. Solution in the 3rd quadrant. Solution in the 4th quadrant. And this has its own mark to give us the 5 marks there. I've shown you that you have changed tan to that angle, and then using your compound angle identity, that will give us our 2, 4, 6 marks. This has a mark. K times 360, K element of integers, it has a mark. Do not leave it out. Solution in quadrant 3 and solution in quadrant 4. We will get marks there. Let's move on to 5.4.2. This requires us to know our trigonometric functions that we are going to discuss just now. You are able to see that we want to find where our f of x will have a minimum value. You are aware that we are dealing with sine x plus 10. So we are sketching the graph of sine in the interval 0 to 360 degrees, and you are aware that the graph of sine is given as follows. Right. We know that our sine graph from 0 to 360 degrees, we have our 90, 180, 270, 360 degrees. So the graph of sine in that interval, we know that it will have a maximum at 90 and 1 and a minimum at 270 and negative 1. Now, from our shifts, even in paper 1, we know that if you are having plus, it means you are shifting 10 degrees to the left. So the maximum value for this one, because we are now dealing, this is the graph of sine x, and then for sine x plus 10, you are shifting the graph 10 degrees to the left because of this plus 10 degrees. So you will get a mark for knowing that it's sine x plus 10. We have already shown it that side. Knowing that the minimum value for sine x is 270, and for the answer, which is x is equal to 260 degrees, you get a mark for that. Now, let's look at trigonometric functions. Our graph, we know that it has an amplitude. Amplitude, we know that it is the difference between the minimum and the maximum turning points of the graph. I've sketched the sine graph, and we have seen that for sine x, our amplitude is equal to 1. Our maximum is 1, so it's half of 1 minus the minimum, which is negative 1, and that will give us an amplitude of 1. Please, an amplitude should not have a sign. Even if it's a reflection of a graph, it should always be a positive value. It's half the distance. Vertical shifts, we know that when we are given the graph in the form sine x plus q, our q is positive, our graph shifts q units up. If it's negative, it's q units down. For sine, cos, and tan, we know the graph of tan, how it looks like. And then we also look for the period. The period, it's what it takes to have a complete cycle. For example, from 0 to 360, that is when we have a complete cycle. For a sine graph, its period is 360 degrees, and for cos, the period is also 360 degrees. For tan, we know that our tan graph has asymptotes and its period is going to be 180 degrees. Now, sometimes you'll be given a graph already sketched, or you are given the equation of a graph and you are supposed to do the sketch. You must know the properties and the characteristics of the basic trig graphs for sine x, cos x, and tan x. If possible, you can quickly sketch that graph so that you compare with what you are given, so that you are supposed to be able to see what has changed on that particular graph. And then we have mixed shifts where the period and the amplitude also changes. We know that our A affects, if it's given A cos x, it affects the stretch, our maximum and minimum. And the coefficient of x, if it's A cos kx, it means this k affects the period of that particular graph. A affects the amplitude. And then the reflections, we know that if it's negative A, we know that it reflects across the x-axis. And we know that if we are having kx minus our p or plus our p that side, we know that this affects our horizontal shift to the left or to the right. Calculating the period, we know that it is the graph's period and you divide by whatever you have as your k. If you have a sketched graph, you are able to determine the period of the sketched graph, then you are able to work backwards to find the missing value of k, or they use any other variable to get the equation of the function. You have seen our mixed shifts. Horizontal shift, it's the plus p minus p. For example, you will have something like this. If you're given sine x plus 30, you are shifting the graph 30 degrees to the left. If it's x sine x minus 30, you are shifting the graph 30 degrees to the right. You have seen with sine x plus 10, our graph shifted 10 degrees to the left. We have explained that one. We are given this graph sketched already, but in the interest of time, I will not give you time to work the question out, but I will work it with you so that we are able to complete the other parts of the revision. Write down the coordinates of the maximum value you are reading from the graph. The graphs are already sketched for you. F of x is cos x plus q, and g of x is 2 sine bx on the interval from negative 60 to 120 degrees. So, like I indicated, it's either you are given the equations you are supposed to sketch, or you are given a sketch, you are supposed to find the missing values on the graph. It says write down the coordinates of the maximum value of the turning point in the given interval that we are able to see. The maximum, it's that point there. What is our x? 30 degrees. What is the y value? It's 2. You get your 1 mark there. Determine the values of x, where f is strictly increasing in the given interval. We did this in calculus. Now, we're dealing with g now, so we are dealing with f now. Where is f strictly increasing? Strictly increasing, we know that it's from minimum up to a maximum, then it starts to decrease from calculus, and we are dealing with f. So you are able to see that from negative 60 degrees up to 0, our f is increasing. Then it starts to decrease. So that's our maximum. That's our minimum. So it's strictly increasing in the interval between negative 60 degrees and 6 degrees. Sorry, between negative 60 degrees and our x value here is 0 degrees. You are able to see that it's between there and the maximum, which is our turning point there. It says determine the values of Q and B. We are able to see Q. It is the graph of Q. We are able to see that its f of x is equal to cos x plus Q. G of x is 2 sine bx. If you look at that graph, you are able to see something there that is happening. I will quickly move on now so that we move fast. I've answered 6.1. I've also answered 6.2. It's between negative 60 and 0. I've talked about that. To find the values of Q, if you check the maximum value for the graph of cos, if we are to sketch the graph of cos, it normally has a maximum value at 1, and that one, the maximum value of the turning point there, you are able to see that it's in between. So we can say our y-intercept is 0.5, but the graph of cos normally has a turning point at 0 and 1. Let's check the next solution. So we are able to see that our Q is negative half. Why is it negative half? Our graph normally has a turning point at 1. It has gone down because the maximum is now at half. That's why our Q is negative half, shifted down half unit. The value of B, you are able to see that our B is going to be 3. We are looking at our G of x. G of x, if you look at the period from negative 60 to 60 degrees, it's a complete revolution. The period for the sketched graph is 120 degrees. 120 degrees. So to find the value of B, we are going to say B is equal to the period for sine is 360 over the period of the sketched graph. Then we get our B as 3 like that. Remember, you may be given the graph and you are given this coefficient. You saw how we get the value of B or the value of A. You divide by the period. So that will give our B as 360 divided by 120 to get 3. If you are given that B value, you say 360 divided by 3 to get the period of the sketched graph. Now use the graph to determine the values of x, for which 2 cos x sine x minus sine 3x is greater than or equal to 0. Now, if you look at this question, you are able to see something. It's given by 2 cos x sine 3x minus sine 3x. If you take out a common factor, 2 sine 3x, you will remain with cos x minus a half. That negative half multiplied by that, it will give us sine 3x, and you are able to see that this is g of x times f of x greater than 0. You go to the graph. Our f of x, where is our f of x positive and where is our g of x positive or negative? Remember, we have this region, negative 60 up to there. Then we have that one, we have that one. You are able to see that our g of x is negative from negative 60 degrees to 0, and our f of x is positive. Negative times a positive gives us a negative, so this is out. From 0 degrees, if you check, our g of x is positive and our f of x is positive. Positive times positive. So from 0 to 60 degrees, we are getting a positive. From 60 degrees to 120 degrees, you are able to see that our g of x is negative and our f of x is negative. Negative times negatives gives us a positive. So we are getting a positive between 0 and 120 degrees. There's an equality there. That is why we are also taking from 0 up to 120. So this becomes our solution. We get our 4 marks there. We move on. 2D and 3D problems. We are solving triangles. We should fill in the missing data, identify or redraw triangles, and always start with the triangle that has more information. And where you have more information, it helps you to link to the other triangle that needs more information to help you work. And we revise our sine rule, cosine rule, the derivations. We did them in grade 11 and you must know how to play around with these. Now, we normally use the sine rule where we have two sides and a non-included angle, or more than one angle and a side. Now, that's when you can use your sine rule. For our cosine rule, we must have two sides and an included angle, or when we are given all the three sides, we can use the cosine rule. Area rule, it's when we have two sides and an included angle, we are able to use our area rule. And please always play around with the variables. It's not always A and B. It can be referring to P, Q, and R. So it applies even if the vertices are no longer A, B, C. So the rule will always work in any given triangle. We have a scenario there in question 7. I want us to quickly read through the question and we will quickly go through that question 7 together and we answer it together. The diagram is given. We are told that a pilot sees an object at point B, and we know that B, D, and C are on the same horizontal plane, and we are seeing that the helicopter or the plane is up there. So they are able to see point B, point D, and point C. The plane is above point D, and you are seeing that this is going to give us our answer there. And if you check, you are able to see a number of triangles there. The first one is triangle ABD. We also have triangle ADC. We also have triangle ABC. So you need to redraw the triangle that you are working with so that you are able to work with one triangle at a time. Do not try and work with the multiple triangles, otherwise it will give you a headache. So for the first question, I can draw triangle A, B, D. Now, I know that this is a horizontal line. If this angle of depression is 30 degrees, I know that for me to get an angle of depression, it must be parallel to the horizontal ground. So here, I'm able to get my angle B also as 30 degrees because these become alternate angles because that is parallel to BD. Like that. So I'm adding information to my triangle. I know that this distance AD is given as h. Using basic trigonometry, it's a right angled triangle. I need the distance AB. In this case, AB is my hypotenuse. And referring to this angle B of 30 degrees, my h becomes the opposite side. So I can use sine 30 degrees is equal to my opposite, which is AD, over the hypotenuse, which is AB, which I want to get. So changing the subject, I'm able to see that AB is equal to, in place of AD, I can put h over sine 30 degrees. And I know that sine 30 degrees is half. It's a special angle. And that will give me h over half. And that should give my distances to h. So the redrawing of the triangle helped me get the value of b. But if you don't, then it becomes difficult for you to see what is happening. So I'll get my 2 marks there. Being able to find that angle and using my trig ratios and substitution, I'll get my 2 marks. We have to show that the distance between the strand object B and the control room at point C is given by BC is equal to that. Now, again, we need to redraw our triangle so that we know the triangle that we are working with. Now, so for question 7.2, I will redraw my triangle. I need the length of BC. I will have my ABC. So in triangle ABC, I'm able to see that my angle, that one, it's 2x. The distance, I have 3h. I have calculated AB and found it as 2h. BC is my third side. So I have 2 sides and an included angle. Which one should I use between cosine rule and sine rule? Cosine rule becomes the way because I've got 2 sides and an included angle. Therefore, I'm going to use my cosine rule. And simplifying algebraic expressions becomes important here because I have to get that expression at the end. And know that you do not just write therefore equals because that information is already given. You need to show all the steps of how you get to that value that you are given there. So I will move on and give you the solution. Our cosine rule, we should be able to see. I've redrawn the triangle. If I can quickly go back so that you see what's happening. Yes, I'm there. Technology wants to fail me. It's fine. Let's move on. We are going to have our A, B, C. I'd redrawn the triangle like that. A, B, C, 2x there. So using our cosine rule, we want BC. So we'll use our BC squared plus our AB squared plus our AC squared. Remember, for cosine rule, we use the angle which is opposite the side that we are looking for. And then we will do the substitution and we will get our values like that. And then we'll get our solution as that. And we'll get, for using the cosine rule, substitution, simplification, and adding the identity for cos 2x as that one, we get a mark. And then expanding and simplifying to get this expression, that is when our fourth mark will go, and then we'll get our full marks. We move on. Now, common errors. Trig graphs, we write amplitude as a negative value. We confuse amplitude with period. Period is in degrees. Amplitude is just our stretch. We make assumptions. Incorrect simplification, I've indicated this one when we're doing our reductions. Incorrect signs when reducing ratios and brackets. Working with more than triangle in our 2D and 3D problems. Using a calculator when the question says without using a calculator. Now, we will move on now to Euclidean geometry. I will look at the theorems that we are supposed to prove. We know them. There is number 2 there. For many years, it was not there. It was introduced in 2021. If you look at our 2021 examination guidelines, we need to go through that one. We know these theorems. Please, candidates, we must know our theorems in words. The statement of the theorem, we must know it so that we link it with the correct reason. Otherwise, we lose lots of marks in Euclidean geometry because we do not know our theorems and we can't link them to the reasons. Linked to that, for any proof of a theorem, we must have a construction or a construction statement. Otherwise, it's zero. If we do not do a construction or if we do not write a construction statement, please be careful. Remember, these proofs are 5 or 6 marks for the grade 11 ones, and for the grade 12 ones, the last two, number 6 and number 7, it's either 6 or 7 marks for the theorem number 7, proving equiangular triangles are similar. Now, please associate your theorem to the diagram. It will make your life easier. So the first one, line drawn from center, we know the constructions that we are supposed to make. Please, if this comes, you do that in the exam room. That is 1 mark already given to you for just construction. Construction. Remember, this one, you are proving first that the triangles are congruent, and therefore, if they are congruent, therefore it follows that AP will be equal to PB. That's what we use to prove. For the second theorem, you are supposed to prove that the angle here is 90 degrees perpendicular, and you are given now that PB and our AP is also given. We are supposed to prove that we are having a right angle there. We get our marks there. The other theorem, know that for every theorem that you are supposed to prove, that statement will be there. Now, this one, we want to prove that this angle here, this angle, this one is supposed to be down there, not up there. You are supposed to show that C1, it's 2 times angle B. So we know the constructions that we make. Naming your angles, you need to do that. This one, we're also supposed to show that C1 is 2 times that angle B, or C1, which is that angle, is 2 times that angle B. So you must also be able to see all the versions of the diagrams that may come there, and you are able to see them. Now, we also have our opposite angles of a cyclic quad, a supplementary. You are supposed to prove that the constructions that you have to make You name the angles O1, O2. We know what to do next. You know. And then we get our marks. The turn chord theorem. I know most of us, if I were to say to you, state the turn chord theorem in words, most of us will not say the correct words in that statement. The angle between a chord and a tangent to a circle at the point of contact is equal to the angle in the alternate segment. Now, these are the theorems that we must know their proofs from our grade 11 work. For grade 12, I know these ones are still fresh. We know the constructions that we need to make. We make a construction, a height, we join. We make another height, we join. And we know that they are sharing the same height. If this is our K, you will find out that this triangle here, and you are able to see that the triangle that I've highlighted shares the same height as the other triangle on the other side. And then the other height, this one, you will realize that it's sharing the same height. If this is our K, our H, it will be our height H. They share the same height. And then we are able to show that they are sharing the same height. And then these triangles here are between parallel lines. If I make another height, they will be sharing the same height. Therefore, they will have the same base, which is PQ, and the same height, which I'll call L. Therefore, they will have the same area as well. Because if you check, APQ is a common triangle, whether the heights are different or not, but the area will be the same because it is the same triangle. What's difficult, it's the one where people forget about the area of this triangle, the triangles underneath there. They are in between parallel lines and sharing a common base. In this case, it will be PQ according to the diagram. We need to understand this so that we are able to prove those theorems. Imagine if you are getting a question like this, you get the proof correct, it's about 6 marks. Already you have 2% in the exam, and that 2% makes a big difference for your level. We move on now. Equiangular triangles, you'll be given information for this one. We know that you do your constructions. AB must be equal to, you name this. For example, I can call this G, and then I also construct DH, which is equal to AC, and then from there I join the two using dotted lines. For our construction, we use dotted lines. Then we are supposed to prove that AB over DE is equal to BC over EF, and you are able to see that these are from different triangles. Now, how do we do it? You will see as we move along. So these are the 7 theorems that we must know their proofs. Just practice them. 1 a day, 5 minutes. By the end of the day, you will be knowing the whole proof. Mark yourself so that you are able to see where you are making a mistake. We move on. For Euclidean geometry, you must know all theorems, the converses that you learned in grade 12, the corollaries, we must know them. We must be able to visualize in Euclidean geometry. The geometry that we learned in grade 8 and 9 and 10, it still applies. The geometry of straight lines, triangles, quadrilaterals. We know that the midpoint theorem is a special case of proportionality. The converses of proportionality and similarity theorems, we must know them. The application for Pythagoras theorem, you will see this as we move along. This we know. To prove that lines are parallel, we should have alternate angles that are equal. Corresponding angles must be equal. And we must also, if we have co-interior angles, then it means that those lines are parallel. Proving a cyclic quad, we know that if the vertices of that quadrilateral are on the circumference of a circle, it's a cyclic quad. Or it has the following characteristics: opposite angles are supplementary, exterior angle being equal to the interior opposite angle, or angles in the same segment. It's another way of proving a cyclic quad. We are also expected to know how to prove that a line is a tangent to a circle. And this one, normally it's an imaginary circle. There is no circle, but you have to prove that a line is a tangent. Similar triangles. We know that to prove that triangles are similar, it's either the sides are in proportion or the angles are equiangular. And then we also know that in these triangles, we use a parallel line to prove proportionality of our triangles. The midpoint theorem, which states that a line drawn from the midpoint of one side of a triangle to the midpoint of the third side of a triangle, of the second side, it will be parallel to the third side and its length will be half the length of the third side. That's the midpoint theorem that is special. Now, a line bisecting an angle, you know that you have to prove that the angles are equal in size, or it has to be stated. We have the types, the numerical, in terms of x and the proofs, proportionality and similarity. We know that we work with one triangle at a time, ratios and lengths, and we know how to use the ratios and rates and lengths. Common area, we know the cases between parallel lines. I've explained this one. Similarity, we know that we have a direct application or indirect application. We will see this as we work problems. So, we must read and understand the question at least twice when we are solving geometry problems. We analyze the diagram by paying attention to keywords. We look at information in the diagram that is helpful and useful, and we add it to the diagram. We can use colors to make our life easy. Please always add information as you get it along the question. It will always open up for the next thing that you are looking for. Implied information. We know that if you have a tangent and a radius, we know that a tangent is perpendicular to the radius. It's implied. You don't need to be told. And we know that for us to develop a solution, you brainstorm and you develop a rough solution. You link information and then you rewrite a formal solution as you move along. Please always do this in your answer book. Do not do it on the question paper, because the question paper remains and the answer book is the one that is marked. Always work on your answer book diagram. Use your colors, enter your angles there. It will help you answer the questions correctly. I will give you 3 minutes to quickly look at that one. Welcome back. Now, for our question 8.1, please read the information that is given there. Read and understand it at least twice before you look at the questions. Before you look at the questions, fill in the information in your diagram. Now, we are given that information. I know that angle P will be 66 degrees. I'm seeing there is a tangent, a chord, and that's tan chord. And indicate all the angles that you are able to get their size in the diagram there. I'm able to see that that one, it's also going to be 66 degrees. I'm having parallel lines. PM is parallel to OR, meaning these are corresponding angles. I'm also seeing a diameter PON, and I know that a diameter subtends an angle of 90 degrees. My M2 is going to be 90 degrees. I'm able to see that I have a triangle there. And using the sum of angles in a triangle, 90 plus 66 will give me 156 degrees. 180 minus that will give me the angle N1 as 24 degrees. Now, I'm also able to see that my OR is equal to my ON because these are ID. So it follows that this angle here should also be equal to that angle there. Angles opposite equal sides. Then I can start looking at my questions now. My angle P is equal to 66 degrees. My reason, tan chord theorem. So I'll get a mark for that and a mark for that. My angle M2, I've already indicated there, it's 90 degrees. I can say angle in a semicircle or angle subtended by diameter. Statement, reason, I get my 2 marks. My angle N1, I've already calculated it. N1 is 24 degrees. These are sum of angles in a triangle. O2, I have already calculated it. It's 66 degrees. My reason is corresponding angles equal. Don't forget to mention our parallel lines. We are seeing that our PM is parallel to our OR. We have to mention, otherwise if parallel lines are not there, you will not get that mark. N2, I've already said my angle R is equal to angle N1 plus N2 because these are angles opposite equal sides. I have one angle of 66 degrees. I can now calculate angle R. It should be angle R plus angle N1 plus N2, 180 minus 66. That should give us 114. Yes, 114. We get 114. We divide that by 2. We get 57. So angle R is 57. And then N1 plus N2 will give us 57. 57 minus 24. That should give us our N2 as 33 degrees. There is the solution for that one. We move along to the next questions. The proof of our theorems. It will come like this. Prove the theorem which states that J plus L is equal to 180 degrees. And this should give us our solution as we will do a construction as a proof. We name our angles O1 and O2. And this is how we will get our solution. So for the construction or construction statement, it's 1 mark. We will have our statements, reason. We will also have this one, statement and a reason. And then we will have to use angles around a point. They will give us 360. We substitute. We divide by 2 to give us our final answer. There is 2J plus 2L is equal to 360. We take out a common factor. We show how we get that 180. We get our 5 marks there. We move on to the next one. Now, on the question that involve our X and Y values, these are the ones that involve the X. How we start determines how we finish. Already, we should start on the obvious. We are able to see that PR is a diameter, therefore this should be 90 degrees. That's our first statement. From there, if this one is 90 degrees, we are also able to see that we are able to get this angle. It will be given as 180 minus X. These are angles in a straight line. From there on, we are able to get our angle R using the sum of angles in a triangle. So if you say this plus that plus r equals 180. We should get our r as x minus 90 degrees. Again, once I get my r, I'm able to see TS is a tangent. I'm able to get that angle. It will be x minus 90 degrees. From there on, I am now able to use my triangle STP. I equate my angles to 180 degrees using sum of angles. I've got my y, I've got my x, I've got that one. Now I'm able to use the sum of angles in a triangle to help me get the solution. And the solution will easily come as that one. I hope you are able to see how we worked that one out. Where you start will always affect how you end up getting your solution. Start from the obvious. This is 90. You are able to get that one. From there on, sum of angles. After sum of angles, you are seeing tan chord because this is a tangent, it's a chord, it will be equal to this angle. Then use that triangle to get your solution. You are able to get that solution there. We'll move right along. Similarity and proportionality. There, we are given our triangles DEG, and we are all supposed to prove that we are supposed to give a reason why triangle DEG is similar to triangle EFG. That one should be straightforward. Please read the information at least twice. At least this one is already given. And if it was not given, you are supposed to show those arcs, to show those angles that are equal, mark the angles that are equal, and then you are able to solve the question. Now, in the interest of time, I will not be able to work out the questions, but I'll flag the solutions so that you are able to do them later on. Similarity and proportionality, we did it last, so we should be able to answer these questions. They are still fresh this year, and we revised them again. Now, if you check, give the reason why DEG is similar to that one. You are given the information. That angle is equal to this one. This is equal to this. Angle G is equal to this angle F. So it follows that you are having in a triangle two angles that are equal. So it follows that this one should also be equal to that one. We are having similar triangles because they are equiangular, or we say because of angle, angle, angle. The length of GE, we have answered that one. The length of GE, we have proven that the two triangles are similar, so we are going to use our ratio of our sides, and our solution will be, you are able to see that our DE over our EG should be equal to EG over our GF, which is equal to DG over our EF. That's how it works. From there, similar triangles, we substitute. GE squared is equal to 45 times 80. That gives us 3,600. This, we want GE. GE is going to be 60 units. We get our solution. Now, we want to prove that triangle DEH is similar to triangle FGH. You are able to see triangle DEH, that one. These we have already proven on the previous one, G, F, G, H. You are able to see that. This one we have already proven. So the solution will be like that. And we get our 3 marks. So these are our vertically opposite angles. These two, we already have them. So it follows that the triangles are similar. They will be equiangular. The third angles will also be equal. Alternatively, when you give the reason angle, then you do not have to show the third statement. But to be safe, always write what you can so that you don't lose marks. The length of GH, we have proven that the triangles are similar. So we are using the similarity of our triangles, and that should give us our GH as 38,4 units. Now, I like this question because it is a different way of bringing a proof. It's the February-March 2016 paper 2 question 10. They are asking you about the proof. So if you do not know the proof of our similarity in triangles, then you will not be able to answer this question. They brought it in a unique way. That is why I had to bring it, so that you do not always expect to see proofs as coming as solid as just prove that this is this. They can bring it in a different way. As you can see there, you will look at it later on. You can take a picture of this, and the solution is given there for 10.1.1. You are able to see it. And then our 10.1.2, you are able to see how that is part of proving the parallel lines. We use it to prove, and then it's asked in a different way. You are able to see how it comes by. We move on to 10.1.3. You are proving the ratios. Now you are able to use that to help us do the proof. In the interest of time, you can quickly take a picture of this question. I will flag the solution for the first one. You are able to see in terms of X again for our grade 12 Euclidean geometry, proving the BPS, our 2.2 proving similar triangles, and then we also have proving the BG squared over, it's also a unique one where you use something that you have found in a previous question to do to help you get what is asked at the end of the question. Now, in summary, we need to always analyze the information given, and we must know which theorems are given before you answer the questions. Like I said, associate your diagram with the theorems. Remember our 4-3-2 diagram, angles and centers. We have our cyclic quads, and we also have our tangent theorems. Please remember them. Always visualize them on your questions when you're answering. Link the statement to the correct reason. Indicate on the diagram on your answer book the information that you can see, but you are discouraged from just writing everything. All statements must be accompanied by reasons. We know that part. One cannot use a follow-up theorem to prove a theorem. I hope you get that part. If the question is asking about an angle which requires like 6.1 is asking you, you cannot use a theorem in 6.2 to answer 6.1. I hope you get that one. Also remember that writing correct but irrelevant statements will not earn you as candidates marks in the examination. Emphasis is on the importance of writing the correct order of statements, improving triangles, similarity. You saw on the one where we're solving, writing our angle y in terms of x. Use of color is encouraged. We refrain from making assumptions. If it's not stated that it's a diameter, we cannot assume that it's a diameter. Now, I would like to draw your attention to the activity where we did a question 6.4 on our trigonometric functions. There is a sine 3x there which is missing. It's given as sine x. Please just correct it. We will see it on your solution. It was supposed to be cos x sine 3x there. Please correct it. Apologies for that. Thank you very much. I wish you all the best as you write your paper 2 on Monday. Let's continue to practice and rest and practice again. Enjoy your weekend. All the best for Monday.